Here is an example of a complete neutralization question. For a complete neutralization, by definition, the quantity of base and acid have reacted according to the balanced chemical equation. So the first step in solving a complete neutralization question is to write out a balanced chemical equation. So NaOH and H2SO4 react in a 2-to-1 ratio when neutralization is complete. Just like in any stoichiometry problem, we're always going to be using the balanced chemical equation to move from one chemical species to another. So after writing out the balanced chemical equation, we are going to determine the moles of one of the chemical species. In this case, we know the volume and we know the concentration of the base, so we can determine the moles using the moles is equal to concentration times volume, and we get a value for the amount or the moles of base. Since in this question, sodium hydroxide and sulfuric acid react in a 2-to-1 ratio, we will use the molar ratio to determine the moles of the acid which had to react with the base in order for a complete neutralization reaction to occur. So we'll simply take the moles of base, divide by 2, and that will be the moles of sulfuric acid which reacted in the equation. Finally, we will use our molarity equation once again to determine the concentration of the sulfuric acid. So we'll take the moles of acid, we knew our volume, and we'll use the molarity is equal to moles divided by volume in determining our final concentration. There's a second method we can use for determining either the concentration or volume of acid or base required in a complete neutralization reaction, which saves a bit of time. This second method relies on the fact that in a complete neutralization reaction, the moles of hydrogen ions will be equal to the moles of hydroxide ions. Note that this does not mean the moles of the acid will be equal to the moles of the base, because for some acids and bases, for example, H2SO4, when H2SO4 dissociates, it produces 2 hydrogen ions for every 1 mole of acid. So if we're determining the number of moles, we will use our moles is equal to concentration times volume equation. But we also need to take into account that these concentrations and these volumes are for the acid or the base, and not for the hydrogen or hydroxide. So what we need to do is come up with an equation that takes into account how many hydrogen ions or how many hydroxide ions are produced by the acid or the base. In this case, our equation that we'll use is this. Note that we see concentration times volume, that's the moles of the acid, and concentration times volume, moles of the base. and we take into account the number of hydrogen and hydroxide ions which are produced right here. Number of hydrogen ions, number of hydroxide ions. In order to determine the number of hydrogen ions or hydroxide ions, we just look at the chemical formula of the acid or the base. For example, magnesium hydroxide. For every one magnesium hydroxide molecule, it'll produce one magnesium ion and two hydroxide ions. So in this case, the number of hydroxide ions will be equal to 2. Here's an example of an acid, H3PO4. For every 1 mole of phosphoric acid, it produces 3 hydrogen ions Let's look again at the equation. The number of hydrogen ions multiplied by the concentration of the acid multiplied by the volume of the acid is equal to the number of hydroxide ions multiplied by the concentration of the base times the volume of the base. Note that this equal sign is true at complete neutralization. So the next step here will just be to determine our concentration and volume amounts that are given. So the volume of the acid was given as 39.2 milliliters. H2SO4 produces 2 hydrogen ions for every 1 H2SO4 molecule. For our base, for every 1 NaOH, it produces 1 hydroxide ion. The concentration of the base is 0.0735 moles per liter, and we needed 50 milliliters of it for complete neutralization. And from here, we just need to substitute the values into the equation and solve for our unknown. Note that these two methods are totally separate. We take into account the stoichiometry of the balanced chemical equation when we're looking at the number of hydroxide ions and the number of hydrogen ions which are produced. So it's important to either use the method using the balanced chemical equation or the complete neutralization formula and not try to combine both of them into one. In fact, if you look at all of the steps that we did in the first method, they are just combined into one equation here, where we found the moles of the base, used the balanced chemical equation 1 to 2, and then divided by the volume of the acid to get the concentration of the acid. So it's simply a method to save some time when we know we have a complete neutralization reaction.